Welcome back. Bearing in mind what we learned in the last video, let us have a go at a harder example. So solve this inequality for x. You can pause the video now and have a go. Okay, welcome back. Let's see how you did. So, we don't like fractions. So if we multiply both sides by 2, which is one of our normal operations, we get there is no need to change the sign because we've only multiplied by a positive number. So we want to group the x values together to one side. So if we add x to both sides, which is also one of our normal operations, we get this. And we want to group our constants to one side. So if we add 8 to both sides, we get this. And now we want x on its own, so now we can divide by 7 on both sides. So we get 2 is greater than or equal to x, or more commonly written as x is less than or equal to 2. Now on a number line, we could represent this. So we have our number line, 0, 1, 2, 3. So x is less than or equal to 2. So we would draw this like that. So 2, a filled in dot, which I will explain in a second, and all the x values less than or equal to it. So this brings us on to our next subsection of representing inequalities on a number line. Sometimes it's easier to see your solution on a number line. So first we need to know the most important detail. If the inequality is greater or equal to, or a less than or equal to, so the key part here is equal to, we use a solid dot to represent the fact that the value it is on is included in the set. However, if we're using just a less than or greater than, we use an empty dot to show that it's not included. For example, if we're using x is greater or equal to 2 on our number line, where we have 2, it's a solid dot and all x values greater or equal to it. If it's x is strictly greater than 2 on our number line, we'll have an empty dot to show that 2 is not included and all the values in front of it. If we have a value of x that's between two values, for example, we have x is greater or equal than 0 and less than or equal to 2 on our number line, we would draw equal to, so a solid dot at 0, 2, a solid dot at 2, and all the x values are in between. Another example is x is strictly less than 3, but greater or equal to 1. So you would have a solid dot at 1, an empty dot at 3, and the values between it. Okay, so a slightly more complicated one. What if you want to draw the x values that are greater than or equal to 1 and strictly less than 2, but x cannot be 0? Well, in that case, you have your number line. And you would draw your solid dot at -1 because it's included in your set. Empty dot at 2. So our x values are between here, but we can't include 0. So we would just draw an empty dot at 0. So this would then mean from -1, including -1, up to 0, but not including 0. And then from just on the right side of 0, all the way through to 2, but not including 2. Our next video will show us how to solve inequalities using graphs.